Assalamu alaikum and good morning, dear students. Today I am going to teach you a creative question based on isomerism, especially geometrical isomerism and optical isomerism. Students, you have learnt about the geometrical isomerism and optical isomerism in your previous lecture. That's why I am going to focus on a creative question related with geometrical isomerism and optical isomerism. So let's start the creative question. Students, you can see a reaction is given in the stem, and based on this stem 4 questions are given here. So students, first you have to know about the reaction. Before starting the stem, I would like to say you the knowledge based question and comprehensive type question. The knowledge based question is, what is stereoisomerism? The isomerism that is caused by the different arrangements of atoms or groups in space within the molecule is called stereoisomerism, that is differed in configuration. Dear students, you know that the organic compounds which can rotate the plane polarized light to clockwise or anti-clockwise are called optically active compound, and there are 2 types of optical isomerism. One is dextroisomerism, and another is levoisomerism. Right rotatory isomerism, and another is left rotatory isomerism. And this is one kind of organic compound which is optically inactive despite it contains chiral carbon. Dear students, I am going to show you an structural formula of tartaric acid. If you observe this structural formula, you will see that there are 2 asymmetric center. There are 2 chiral carbon atoms, and if I imagine a plane of symmetry, I will get 2 identical parts. I can say here there are 2 identical asymmetric centers. There are 2 chiral carbon atoms. So students, if I fold one part to another part, they will be superimposable to each other. One half is superimposable to another half. That's why if one half rotates the plane polarized to clockwise, then another half rotates the plane polarized light to anti-clockwise. As a result, the final rotation of plane polarized light becomes 0. That's why tartaric acid is known as mesotartaric acid. Mesotartaric acid is optically inactive compound. Actually, this optical inactivity happens due to the internal compensation. That's all, students. Mind it, first you have to write the definition of meso compound, then you have to draw the example like tartaric acid, then you have to show the symmetric plane. symmetric plane, and then you have to explain the reason of optical inactivity of tartaric acid. That's all about the question number B. Now come to the question number C. Compound A of the stem shows optical isomerism. Dear students, now you must identify what is compound A, and it, of course, it will be based on the stem. So dear students, come to the reaction of the stem. First you have to write the stem. Students, now look at the whiteboard. If I write here the reactant, this is actually 2-bromobutane. 2-bromobutane reacts with aqueous solution of potassium hydroxide to produce butanol 2. Butanol 2 and potassium bromide. And if I use here alcoholic potassium hydroxide, I mean potassium hydroxide dissolved in alcohol, then a hydrogen bromide is reduced from the reactant. This is actually elimination reaction, and we will study about the elimination reaction very broadly. So students, one hydrogen atom from the third carbon and bromine can be reduced here. So the compound will be CH double bond CH bond CH3 plus, and if one hydrogen atom from the first carbon, it will be CH3 CH2 bond CH double bond CH2 plus hydrogen bromide. Students, this is butene 2 and this is butene 1. So dear students, I can say here B compound is butene 2 and the percentage of B compound is 80%, and C compound is butene 1 and the percentage of C compound is 20% plus potassium bromide plus water will be the produced. So students, already I have identified the name of A, B and C compounds according to the stem. The question B of the stem shows optically isomerism. Dear students, first you have to write the definition of optical isomers. The type of isomerism in which two or more possible isomers with same molecular formula, structural formula and same physical and chemical properties but differ by their action on plane polarized light to rotate the plane of polarized light in different degrees is called optical isomerism. Then the isomers are called optical isomers. Dear students, if I write the structural formula of butanol 2, CH3 bond OH bond C2H5, this is butanol 2, and the butanol 2 contains a chiral carbon, I mean an asymmetric center. And dear students, you know that compounds which contain asymmetric carbon are optically active and they shows optical isomerism. And this type of compound forms non-superimposable mirror image. I mean, its mirror image is non-superimposable to each other. Its one isomer rotates the plane polarized to clockwise. This is D-butanol 2 and this is L-butanol 2. D means dextratory, I mean right rotatory, and L means left rotatory. So dear students, it is proved that compound A shows optical isomerism. Now students, come to the question now. D, which of the compound between B and C gives geometrical isomerism? Dear students, in this case first you have to write the definition of geometrical isomerism. The type of isomerism in which the compounds have same structural formula but there is difference in their relative arrangement of atom or group in space around the carbon-carbon double bond or about single bond in cyclic compounds is called isomerism, and the compounds are called geometrical isomerism. So dear students, we can see butene 2 produces here 80% and butene 1 produces here 20%. Students, we will study in the elimination reaction part what is the reason of different percentage of the products, but now I would like to focus only the stereoisomerism here. So come to the point here. Butene, if I write here the structural formula of butene, if two hydrogen atoms are at the same side of the carbon-carbon double bond and two methyl groups are at the same side of the carbon-carbon double bond, then it is one configuration, and if the methyl groups are opposite sides of the carbon-carbon double bond and hydrogen atoms are opposite side of the carbon-carbon double bond, then this is the another configuration, and one configuration can't convert to another configuration by carbon-carbon free rotation because there is carbon-carbon double bond. And students, look at my hand, there are two markers here and consider it carbon-carbon double bond. They can't free rotate. Actually here carbon restricted rotation is happening, but if there is only one bond, the free rotation can be happening. I mean, if free rotation can happen, one configuration can convert into the another configuration easily. Here as well as due to the carbon-carbon restricted rotation, one configuration can't convert into the another configuration easily. That's why two different configurations are arising here, and here actually according to this condition compound B shows geometrical isomerism. Here A is not equal B, dear students. Here A is equal hydrogen and B is equal methyl group, and when the two same groups or atoms are same side of the carbon-carbon double bond, then it is called cis isomer, and the name of this compound is cis butene 2. And when the two same groups or atoms are in the different sides of the opposite sides of the carbon-carbon double bond, then it is called trans isomer. Trans isomer, and the name of this compound will be trans butene 2. So students, compound C, if I write the structural formula of compound C, you can understand easily. Compound C does not follow this condition, because here 3 hydrogen atoms are present, but as this condition I need the 2 different atoms or groups here, but here 3 atoms are same. So the compound C of this stem will not show the geometrical isomerism. So dear students, I think you understood about the whole creative question, but if you have any confusion, you have to go back about the stereoisomerism, and then again you have to come in this creative question. Students, no more today, and goodbye.